I live inside my own world of make-believe. Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Tape my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be tight laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.
We like to think we have some form of control still, making our constant binary choices and voicing our equally shallow opinions more loudly or quietly. Most people can't even decide.
Hello everybody, I am back today with a new kind of stream for this channel. I'm going to be working on some development of software that I guess is, in theory, relevant to hacking. It's very unlikely that I will actually use this particular program that I'm going to work on in any of my hacking work. But the general structure of the program, or what the program is designed to do, is definitely an important element in a lot of the binary exploitation work that I have been doing elsewhere on the stream. So an example of that is, just make sure that I can hear stuff. Yeah, okay. The audio is coming through. So what I'm going to be working on is a instruction decoder for the x86 instruction set. And if you don't know, an instruction decoder is basically a program that's going to take the binary representation of a particular instruction or a stream of instructions, sequence of instructions, and it is going to decode from the binary encoding that is mandated by the design of the physical hardware, and it's going to decode it into some other kind of data structure. That data structure depends on how you want to use the decoded information. Generally speaking, it's still going to be in the general shape of a sequence, but each element in that sequence can have more or less information within it, depending on exactly what it is you need to know about each instruction that's in the stream. So the biggest place where this kind of thing gets used, or I mean, generally speaking, this gets used in static analysis tools. So any sort of reverse engineering tool, any disassembler is going to have, as part of its process, it's going to have a decoder element. There's a lot more work that goes into disassembly than simply decoding the instructions. You need to do a lot of stuff to figure out which bytes within a given binary file or a given representation of memory for, perhaps a running process. If you've got a dump of the memory, you need to figure out which bytes actually represent instructions and decode those instructions. Then you need to do additional levels of analysis on it to, for example, figure out where the jumps go, where the functions exist, how certain constructs are represented. There's a lot of different stuff that you do in a disassembler, and I certainly don't know all the details of those things, but all of those additional analysis steps, things like figuring out which set of instructions, which group of instructions represents a particular function, or what is the like the instruction target for a jump instruction, for example, because maybe the jump instruction just says jump back 18 bytes. Figure out which instruction is at the location 18 bytes earlier, that kind of thing. All of that is made easier if you have a data structure that represents the actual instruction stream, which is not the same data structure that is the actual encoded bytes of machine code that are given to the processor. At least on x86. It's maybe not as stark of as drastic of a difference on other instruction sets. I'm not as familiar with other ones though, so it may apply exactly the same on those others, but what I know of the x86 instruction set, at least, is that it was designed to be as compact as possible, so that a lot of instructions can be encoded in a single byte. A large chunk of additional instructions can be in 2 bytes, that sort of thing, so that ideally each program, that is within the range of like common programs that you might create, each of those are going to be relatively short to represent the actual instructions in memory when you have compiled it down to the machine code. The reason for this is the very early x86 machines, like the 8086, simply didn't have a lot of memory. I don't remember off the top of my head what they were, but it was certainly measured in kilobytes. So you're going to need to have, as a general rule, you're going to be working with an eye towards compactness of memory representation. So the actual format of the instructions was designed with that in mind, and there's also a lot of features to what not just what instructions exist, but how you can encode the operands for your instructions in such a way that you can minimize the number of instructions you need. So that's part of why it's considered a complex instruction set. A CISC instruction set. Where we go? Complex instruction set computer. And single instructions can execute several low-level operations, load from memory, an arithmetic operation, and a memory store. There might be a few that do all three of these, but at the very least, you have some things like I can load a bit of, I can load a 32-bit piece of data from memory into a register, and the address in memory where that data is located is going to be the value from this register plus 3 times the value from a second register plus 8 or something. And we'll get into that, but that's like, there's ways of encoding all of that information into a single instruction. Whereas probably in a RISC instruction set, a reduced instruction set computer, you would need to represent that as 3 or 4 different instructions, perhaps. Certainly more than one instruction. As you first load in the value from one register A, then you multiply that by 3, then you add 8 to it, then you add that to the value in register B. That's your new memory address. You store that into, or maybe the adding it results in it being in memory in register B, and then you say, okay, load the value from the address in register B, stuff of that nature. Like you end up with a lot more instructions, but the idea then is like your computer is able to execute those instructions a lot faster, perhaps. That being said, it's still, because it's multiple instructions and no single instruction is going to be shorter than 1 byte, it's ultimately on the very low end of instruction sizes. The RISC style is going to require more memory to store the instructions, and that then has different impacts on things like the instruction cache, how big that can be, or needs to be rather, stuff of that nature. So part of the complex instruction set computer motivation, at least for the x86, really comes out of having to work very conservatively with the amount of memory that was available. And what we're going to see is when we go through the manual, in addition to the fact that things have been added to complicate the situation quite a bit more, especially when they added 64-bit on top of everything. There's definitely complication that is inherent in the original design with this mod r/m and the SIB, and then displacement or immediate. Like, we're going to get into all of these details, but just know that the reason that it's so complicated is they were trying to pack as much, let's say, semantic density into these instructions, so that every bit in the instruction really was meaningful, and you used the absolute maximum amount of the space of a single byte instruction as you could, or a 2-byte instruction or something of that nature. So it really makes this a little more complicated than would be ideal for the decoder process. But that's part of the fun is learning all of these details and then being able to correctly implement the algorithm for decoding them. And so that's what I'm going to be working on with my C program, which is right now just, even less than a hello world. It just returns a success result. So yeah, my goal is to really help solidify the details of the binary encoding of x86 instructions in my own mind by way of writing code that actually has to implement that algorithm, so that I can understand a little bit better what each of these pieces are doing. Because I've read through some of this. I don't know that I've necessarily read through the manual in the amount of detail that I'm going to be reading through it in this stream or sequence, series of streams about coding this, writing up the decoder. But I've certainly looked at it or looked at other resources trying to explain the binary encoding, in part because sometimes when I'm reverse engineering and I see, okay, the disassembler has printed this instruction, but maybe there's some confusion on my part, or I think there's maybe different varieties of the same instruction. What does it mean, for there to be different varieties of the same instruction? So if we look at the move instruction, we can see what might be represented in the disassembler's output as just MOV for move has a large variety of different bit encodings, or different bytes that would represent that same instruction. And why are they different, and what specific one am I dealing with in any particular case when disassembling a program? I think it turns out, as I've gotten better at it, it doesn't matter quite as much, or I'm just used to seeing what those varieties are. But certainly I've had times where I've tried to work out, what the exact binary representation is, and then have ended up going down this sort of rabbit hole of trying to work out how that is encoded. Why is this 8B and this is 8.8, that sort of thing. And which, this might be purely arbitrary decision between 8B and 8.8. I'm just making an example here, but why is the version of this that is referencing EAX, let's say, for this 8B versus the one that's referencing EBX, if we're talking about a register operand, those are a different set of bytes for the full instruction, including operands. And so why are those different? And I've gone down that path, and really, like, each time I've tried to learn it, I've gotten a better sense, I guess, but not necessarily a good enough sense to really have it solid in my mind. So probably the biggest motivation right now for me working on this is to go back through it and really make sure that I fully understand it. Because I think it will be helpful in general for me to have that additional layer of knowing how the machine code encoding works. There's different aspects to, you know, how a machine code series of bytes differs from the assembly representation for that. And, you know, not all of those are about the, like, encoding it as binary as a sequence of numbers, as just, you know, sequence of bytes, versus writing the mnemonic for the instructions and stuff of that nature, and, you know, and the names of the registers. There's other layers to it in terms of, like, not having available symbols or having available applying a name to a particular location for a jump target or something. There's lots of stuff that are different there, and I feel like I understand that level of difference, let's say, but not necessarily fully understanding the binary encoding. So I want to shore up my existing knowledge. So that's primary reason one. The second reason is I would like to use this as a project to help me get better at Rust. So my goal right now is to write it first in C, have an understanding of what the algorithm is, at least a core piece of it, because there's a lot of instructions in x86. I don't know if I'm going to bother yet with, like, trying to have a complete decoder. It depends on how fun I find this process. I'm going to start with, like, the very early 8086 set of instructions, and maybe, you know, get around to SSE, maybe get around to 64-bit, the AVX instructions, all the, like, SIMD stuff, you know, just adds more and more instructions on there, and they work differently and have different let's say design patterns, maybe, as well as the floating point instructions, like the x87, I believe it's called, is another extension to this instruction set for floating point stuff, and it works a little bit differently because it's about, like, it's got a stack of floating point values, and I haven't done a lot with that, but presumably there's different aspects to how it's encoded. If it's not talking about registers or memory addresses all the time, maybe there's another third option for what the operands could be, or I guess fourth, because there's immediate values as well, and those are available in the standard 8086 instruction set. So I don't know if I'll go through all of that stuff, basically, but I want to start with that and see if I can take this program, which is if I can get some subset of the x86 instruction set able to be decoded. If I can get a program that's working like that, and I have a good understanding of what the algorithms involved are, then I think that's a real world kind of thing, as a meaningful case for me to then recreate it in Rust and use that as my goal to focus my learning of Rust, so that I can start getting, better at that, and maybe push on to larger applications and stuff in Rust, because I would like to learn it. And just doing tutorial stuff is not often a winning strategy for myself, I've found. It's better for me to have a real world project to focus on, either an existing one that I'm just trying to fix some bugs with or add a feature to, or a relatively small program that I understand pretty well, just in terms of what the code semantics are, what the algorithms are and stuff, and then try to translate that to Rust or whatever my target programming language rather. So that's the second goal. The third goal, much more hypothetical and long-term, is, I've looked at several different x86 decoder encoder programs. There's an official one from Intel. There's several open source ones that I've looked at. Because again, this is like an element that comes into play in a lot of different tools related to binary analysis and, potentially exploit development, hacking, anything that builds on that, reverse engineering, certainly. So different people have done the same thing that I'm planning to do, basically, and take a stab at writing their own. And the main theme that I've noticed through all of them is they do tend to have an interface that is doing a single instruction decoded from the sequence. So you give it a sequence of bytes, basically, which represents, the memory that would be for some, area of instructions in the memory space that would get probably loaded into the iCache and then decoded by the CPU as it starts processing those instructions and actually doing the work of them. And so you give it that stream, and then and you call the function on it, and it returns one instruction, and then it tells you like how long that instruction was, so that you can move your cursor, index, whatever you want to call it, in the stream that many bytes forward, and then you run it again. You call the function again to say, give me the next instruction. And that's your sort of process that's your interface for decoding the whole instruction stream. You just do it one instruction at a time, which makes perfect sense to me, especially for x86, because the instruction sizes are, vary from 1 byte to, I think, 15 bytes. I don't know if the 15 bytes includes the operands. Probably. I think it would be kind of wild if it was 15 bytes and didn't actually have the operands in it. But when you're doing the decoding, you are including the operands in there. So it's anywhere from 1 to 15 bytes, I guess, that you end up consuming for the next instruction. And as a result, you can't just like pick an arbitrary location and say, okay, every third byte we're going to decode another instruction, because if the first instruction is 5 bytes long, then starting on the third byte means you're decoding a value that is not the beginning of an instruction, and you'll just get garbage from that. I mean, it might be a real instruction, but it's not what would actually be executed by the program, by the CPU. So it makes sense to have this like one at a time sequential process, but I do have some ideas of how you could get around that in order to do bulk, sort of what I consider in my mind bulk decoding, where you give it an instruction stream and it tries to decode all of the instructions, or as many instructions as possible simultaneously, primarily by working out first what the sizes of each of the instructions are, and then once it knows the sizes, decoding each of those instructions in parallel. Because once you know the sizes, it really is a completely parallel process. But again, that's like incredibly hypothetical for me, because I don't even have code that could decode one basic instruction, like a NOP or something, which is probably the instruction to start with. I mean, it's so simple that it may not be worth starting with, because there's just nothing to it. It doesn't imply anything about the structure that the rest of the program needs when decoding more advanced instructions. NOP is not simple, says N. Permyakov. Well, I'm curious what you mean by that. I have some thoughts on what you could mean by NOP is not simple. There's definitely different kinds of NOPs. Obviously, there's multi-byte NOPs that are, it's something like add on x86. That I don't understand. I mean, maybe it, has that in the behavior if I was writing an emulator or just wanted to understand what the CPU is doing. But I would think from the perspective of decoding an instruction, there's no designated NOP instruction. There is. It's 0x90 is a single byte instruction that is just NOP. This guy. And there are definitely ways to write multi-byte instructions that represent a NOP. So that might be an add in some cases, or I'm sure there's a wide variety of ways to get like a 5-byte NOP or something. But there is a single byte NOP if that's what you end up needing. And from the standpoint of decoding this, I would just have an if statement that's like, if the byte is 90 hex, then I don't know, whatever, depends on what my data structure output is going to be, but it doesn't imply a lot about how I would decode a more complicated instruction, something that had operands, for example, or something that had multiple representations. I guess technically NOP has multiple like there's even multi-byte NOPs that are directly written into the spec for the instruction set. I hadn't known about that before just now. There's definitely elements to the shorthand that's used. So this Felix Cloutier website that I use as my like search sort of quick reference database for x86 instructions is automatically generated from the manual. We'll be going into the manual because their automatic generation pages don't include this explanatory text. It decodes to exchange EAX. Okay. Interesting. I mean, I guess what's very interesting to me on that front is if it says the opcode here is 90 plus RW, right? Then the RW here is referring to some register so that you could exchange something with AX, or exchange something with EAX if you're in 32-bit mode, I guess. And so is 90 just happens to be the let's see, just happens to be, the bit pattern that you get if the 32-bit register is also EAX? Is that essentially where it works out? So you have exchange EAX. EAX happens to be 90 and maybe like 91 or 9 and then some other bit being set. It would be EAX, EBX, for example. Okay. Interesting. Yeah, I had not heard about that at all. Especially because, all of the tools that I use are going to represent that as NOP rather than exchange EAX. I don't think I've ever seen a disassembler, or anything else that's like giving me the decoded instruction stream, present it as the exchange instruction. It also wouldn't terribly surprise me if the hardware was hard-coded to recognize, hey, if you're doing an exchange for the exact same memory address, the exact same register, as because these are instructions that are like are fixed to AX, EAX, RAX, whatever. Basically, they could detect 90 is also doesn't do anything, right? So I don't know, but there's all kinds of weirdness that ends up happening in the actual physical implementation of this stuff. So, and that doesn't end up mattering to me. I guess that, that's definitely neat to know. I don't think it ends up impacting on my decoding, because I don't think I would ever want to decode. I guess what you're saying is like, I could hard code 90 to decode to representation as NOP, but then 91 or whatever, EBX would be, if we had EBX here instead of EAX, that's not going to be hard coded. That needs to be represented as the exchange instruction. And so, yeah. Don't know if it's all that common in instruction streams, though. I have seen it. Well, it's hard to know because I don't end up like. Well, I don't think. I mean, the when you say you'll have to distinguish between NOP and regular exchange anyway. Yeah, I see what you're saying. Like, so if I'm going through an algorithm that is decoding based on, we are getting the opcode, and trying to figure out. See, this is okay. So this is again, a piece that I simply haven't looked into it enough. But when we're talking about a 1-byte opcode, such as 90 here, right? How is that 1-byte opcode indicating, and apologies for me switching to the very bright PDF. I don't know how to turn the PDF dark mode. If you have any ideas in chat, let me know. Other than, I don't know, processing it through some program. I'm not going to do that. But so let's say we're looking at this instruction here for a register D word. I guess that's what the RD is for. If we want EBX, okay, because I wasn't sure if the flashing between a dark and a bright screen is off-putting to people or not. It's a little bit glaring for me, but I can definitely deal. So again, if we have exchange EAX EBX, is that still a single byte, or is that 90 and a second byte, where the second byte is got the mod RM stuff to indicate EBX basically? And is that what you mean by you have to distinguish between a NOP and an exchange? Because yeah, at that point, I don't even know what the fuck. Because if you've got a 90, that could also be a 90 followed by a second byte. Unless that second byte is certain to be something that couldn't be an instruction. I don't know if I'm making myself particularly clear, but let's say the sequence is 90 and then 05. It could be encoded in the first byte. Okay, because that's what I was sort of working from, the concept of instead of 90, it might be 91 or 92 or 93 or something. I don't know. But if it actually starts with 90 and then has more than one byte potentially, that's where I get into, I don't understand how the CPU can do it either, because how do you know if that 90 is supposed to be a NOP or if you're supposed to be using multiple bytes? A baseline assumption that I'm working from here is for any sequence of bytes that the CPU would see, it would know whether or not this is a complete instruction or if there are potentially more instructions. And at some point it's going to get a sequence of bytes where it knows, okay, there are a fixed number of additional bytes for this instruction, which might be 0 or might be, more than 0, but it's it doesn't have a okay, this instruction could be done now, or it could have 3 more bytes in it. Because at that point I don't know how the CPU would decide which instruction it's dealing with. So I'm going to assume that the encoding works in such a way that, much like Unicode, if you're dealing with UTF-8, based on the bytes that you've seen already, you know whether or not you have more bytes in this character. Yeah, the first byte of 90 must be enough to tell what instruction it is. Right, like, yeah, it just doesn't make sense to me. As you say, it's common sense to do it that way. So, okay, I'm going to work on that assumption. And I think that's what the plus here is talking about. Of course, they also have like the Rex header plus, and this means that, you know, this is 1 byte and this is a second byte, I guess. But maybe doing the plus without spaces in their shorthand representation is how that gets represented as 90 plus some offset that represents what register we're talking about. We'll see. I don't know. There's so many parts of like the shorthand that is used in the manual, and this comes out in this sort of reference website that I don't yet understand. And, you know, hopefully I will have a better understanding of all of that as we go through it. So I see your point that like maybe 90 is not the way to go. I don't know that there might not be like a simpler instruction in that case. I mean, I'm not really like going through all the instructions in my head that I'm aware of, but anything that's got an operand, you know, sort of already jumps to a level of complication that starts to you know, involve doing the real deal algorithm of decoding according to how these things are broken down in the instruction format specified here. So I think there's not necessarily that much incremental way of getting up there. Let's see. If you hardcode 90 as NOP and not try to parse it as exchange further, then yes, NOP is a single 1 byte instruction. That's easy to start with. Yeah, I mean, that's what I was thinking of, but hard coding it, like, if it equals to 90, then the output is a NOP, is like not actually that helpful. Maybe it's helpful enough to have a thing just to start writing, but like that code is going to get thrown away because it doesn't make a lot of sense to have that one-off kind of hard-coded thing when pretty much every other instruction is going to go through some other code path that actually pulls out the bits from within the byte to figure out, you know, what the indicators of the operand types and what the, you know, if it's a register, what type of register or that kind of thing, what the SIB is, etc. Obviously, that's going to be a different, you know, a subsequent byte. But yeah, I think maybe the thing to do is to just start. Yeah, I mean, we might as well do that. It just feels like that is so simple that I could code it in a way that is like pointless, and I don't necessarily know. I don't know enough in my head yet to even know like what a non-pointless design for that would be, right? So we can write that up real quick. We can do, I mean, this, I guess it, you know, it starts to force me to make certain choices. So let's call it this. And we're going to do, can I do it this way? We're gonna see how bad I am at C as we go through this as well. Yeah, like, so let's say we have an instruction stream that's just a single 90 hex byte, and I could do, we're gonna do an extremely simple representation of the decoded instruction. So right? Like, let's say we just return an integer, and the integer represents the operation as a unique, like basically as an enum. I guess I could write it as an enum. So I guess we'll find out when I compile it that I wrote that wrong, I guess. And so we do it this way. Change return type to int. Oh, maybe it's because it's flowing to the next thing. So let's see if whatever, right? So I could do something like this, assuming that I am not writing things very poorly. Oops. What did I? Oh no. Oh. Standard lib.h. Okay. What do I have here? Result of comparison constant. It's always false. Okay, we'll do it this way. Oh, I guess I needed that as double quotes. I don't know. So I don't even know if I'm going to try using this because it's so pointless, right? But like, if I start off my process as this, is this getting me closer to something? I'm not sure. I've already defined a data structure for the representation of the decoded results. Yeah, so I'm writing it mostly. So N Permyakov asks, are you writing your own instruction decoder just for self-education? Mostly. There's a couple layers to it. The primary one is to really solidify my understanding of the x86 binary encoding. The second one is that I would like to take the result of doing this in C and then rewrite it in Rust as a way to practice Rust, because I don't know it almost at all, and I would like to start learning it, and I find that it works better when I do a real project with it. But I need to do a project that is something that I, when I start writing it in Rust, I already know what the solution is going to be, because I don't want to try to figure out what the project code has to be as well as how to write it in Rust, if that makes sense. And this is just the thing that has been like sitting in my brain as like, I should do this at some point. So I figure this is a good project. It's relatively small if I don't try to do the full instruction set, let's say, if I keep it to a minimal set. And then eventually I would like to play around with like different ways of doing the decoding to try to do it more in parallel. I talked about this a little towards the beginning of the stream, but like, if you can work out the lengths of all the instructions and go through that, and maybe you can figure out a way to do that faster than doing the full decode process, then in theory you could decode those instructions in parallel, because you already know which slice of the sequence of bytes each instruction represents and stuff like that. Because I've looked through in a relatively cursory way, I looked through other people's decoders, and they're all this like in decode one instruction at a time kind of thing, which is what I'm going to do for this implementation as well, because it's the most obvious, and like, there's good reasons for doing it that way. But I'm very curious if you could get around sort of feeling forced to decode one instruction at a time if you could actually do a lot of the decoding work in parallel. But that's like, you know, as I said earlier, it's incredibly hypothetical because I don't even know how to decode one instruction at a time right now. So yeah, I don't anticipate actually making use of this code. You're right. Be prepared to deal with a lot of hairy details is exactly correct. I mean, that's part of the appeal of it to me for whatever reason, is like I want to then know all of those details. It's been sitting as a thing that I, only barely understand for all the time that I've been doing like reverse engineering work, which I'm not going to put myself out there as like, great at reverse engineering or anything, but it just feels like a piece that like I would like to know this additional, even more low level, let's say, element to it. And I've always got these ideas of like working on emulators and stuff of that nature, and I feel like this is a necessary part of going that extra mile into building more tools. So I'm gonna at least give it a shot, and we'll see if that works out. So you're interested in x86 instructions, but only at a high level of possible modes, prefixes, and other options. So I mean, I think I understand what you're saying. But at the same time, it feels like, how are those, how can those be extricated from the lowest level details of like the fact that you've got these 3-bit chunks that represent, I think they use 3 bits to represent one of, which register you're using, because there were 8 registers or whatever, right? And so 3 bits is all you need to represent that. And then they've got other pieces that are in 3-bit chunks, and like I just don't know how you could necessarily separate out those things, because knowing whether or not you have the like Rex prefix, or you're doing the like 32-bit mode stuff, or I don't know, it feels like those are all intermingled with understanding exactly what instruction you're dealing with. Don't see yourself ever writing your own decoder to learn what I want to learn. Fair enough. I think my reason for trying it out is this feels like how I will be able to really learn it. I only get so much out of like reading explicitly introductory / like pedagogical material. And I mean, I guess technically the manual falls into that category. It just feels like the most dry version of that, paired with being the most, in theory, the most accurate. I would say there's probably folks that you can talk to that'll say it, it may claim to be the most accurate, but there's all these flaws, all these details that they have wrong. Hopefully the instruction format part of the manual is not where they have the problems, the errata or whatever. But because they are trying to be as complete as possible, I feel like just reading the manual straight through is like, for me, the most dry way to receive this information. And it's not going to click into my head. It's not going to like really get stuck in there if I am not forcing myself to make use of that knowledge by having to then write a program that actually correctly implements the behavior described in it. I found that I'm able to read a lot of text, and then that information just sort of flows out of my brain as I go pay attention to something else. Whereas it sticks a lot better if I had to like puzzle over it, have some kind of bug, and then analyze why my code isn't working the way that I wanted it to, and realize, oh, it's because I didn't, what I thought I read in this paragraph here is not what they're saying, or something of that nature. Yeah, I mean, it's very wild, and I understand the logic or the reasoning behind why the encoding is as it is, because they needed to conserve space as much as possible, like take as little memory as possible for representing the instructions back in the early 80s, when these were like some of the relatively early microcomputers, and they just didn't have much memory to work with, and now we're stuck with it. But at the same time, if you think about it, that's how many generations of people that have taken on this challenge of working on tools to deal with this decision that was not made very forward thinking. And I don't know, why don't I join them in this lineage? Meowcat, hi, how's it going? Thanks for joining the chat, and thank you and Permnikov for joining today and talking with me. What can you do with this knowledge? I mean, I think that is a good question. I'm not convinced that I have a very clear use of it at the moment, because like if I'm doing binary exploitation stuff, or I'm doing reversing stuff, like I'm going to be using existing tools. I'm not going to be relying on this janky software that I'm about to start writing eventually, I say, as I continue to talk rather than go into the details of what I need to be writing. But I'm going to reach for Radar. I'm going to reach for Binary Ninja, whatever, Ghidra, whatever tools I have available to me, and take advantage of the fact that they are relatively well tested, not completely bug free certainly, but for the most common instructions, it's very unlikely that they are going to give me the wrong results. It's very useful when patching instruction streams in place, for example. Yeah, I can see that for sure. If you really need to, I mean, like, yes and no. I think yes, it is. It would be a tool to use for that for sure. But also, like, I could probably achieve that right now by, putting together a few different pieces of existing tools. At least, I can think of doing that in Cheat Engine without having to know any details. I can write it in assembly, and then Cheat Engine will compile that assembly, or it will assemble it rather, into the right machine code, and then replace the memory as necessary. So it's like kind of yes and no. I think the most obvious use case for me for having a piece of software like this, standalone decoder that I'm working on, would be something to find ROP gadgets. As long as you can tell it which memory regions within a file are going to be the executable areas. If you give a little bit of like load it up with BFD or something that'll process your binary format, L for PE or whatever you have, and then you can just run through the memory in those regions and decode everything, and then you're just doing kind of a grep on the decoded results in essence. Like, so ROP gadget tool seems like the most immediate obvious thing that doesn't need a lot of additional layers, whereas like a disassembler obviously depends on a decoder but has so much additional stuff to be able to give you meaningful results that a disassembler is not the thing that I'm planning to go towards, I'd say. As much as I think it would be really cool to build a disassembler, I'm like, that is long-term goals at best. And then Ty Cabmo, welcome to the chat. Thanks for joining. Well, a lot of time when you start out learning one thing, you actually learn something else too. So I say learn everything else you can. Yeah. Or learn everything you can. I think that is absolutely correct. Like, you don't want to, get too hung up on, I'm going to learn a very specific thing. Kind of let the learning take you where it takes you, and so many things are interconnected that it would be hard to not not end up learning additional stuff. So I think that's absolutely true. And learn everything you can seems like that's what got me into the place that I'm in right now, is just in sort of endless curiosity for the details of how these things work. I can characterize it along several different lines. I think more recently, my thinking goes towards like, well, somebody at Intel, and more than one person presumably, had to put in all the work to come up with this instruction set and how it is encoded, and had to think about all of these additional concerns and stuff that come into play when you're actually working on hardware for stuff, and must have had this long history of previous hardware designs that they're sort of building from as their basis of knowledge, and just sort of a recognition of the work that those folks put in developing this. And in me understanding it, there's almost a certain degree of conversation between us over through the years, and I sort of like that concept, I guess, of just, I can maybe better understand what was going on in their mind by understanding the details that they came up with over 3.5 decades ago or whatever it was. And sometimes it's fun to just think about that, go outside and look at all the stuff that's out there and think about all the engineering hours that were put in to coming up with how to design this building or this car or this machine, or the millions and millions of things around us that somebody had to like spend significant chunks of their life on. Okay, so we're gonna get into it. In terms of strategy, I think rather than maybe identify what would seem like a very simple instruction, like what I thought NOP was, before finding out it's actually, even that's not as simple as I imagined it was. I think a good initial goal would be to be able to decode single byte instructions. I'm not going to say that the initial step in that goal is every instruction, but at least one single byte instruction, decode it. And in that sense, maybe it would be good to pick an instruction that has operands, but maybe doesn't have memory and register possible operand types, basically. So like a move instruction, might have too many different ways that it can work out. Granted, they are different bytes for these. But yeah, it's like, I don't know. See, I'm already like not wanting to just read through the manual. It's not a very fun thing to do on stream, I'm guessing. So I think what I might do is start working on coding up something to decode a particular variant of a single instruction, or be able to decode a couple of different variants of that same instruction. And then after the stream, go back, read through some of this stuff. Maybe it will make more sense after that and allow that to inform how I go about things on the next stream. So let's see. Sand sifter. There we go. Okay, so the thing that I'm going to start with for this is this XOR EAX. Oh, interesting. It's forked from a Battelle repo. Okay, I guess it started being built by Battelle and then was taken to the personal account of the guy that made it, I think, is how this worked out. So this is a thing that I found through a talk that I was watching where basically this gentleman, maybe he's got his real name on here. Somebody, is it Alex Domas? No, is he on Twitter? Christopher Domas, that's who it was. Yeah. And he does a bunch of like trainings and stuff that I would like to take if I had any money. So he did a project to try to work out what all the actual x86 instructions are that are recognized on any particular processor. Because when you really get down into it, the literal instruction set is what is recognized by a particular processor. Since there's so many different x86 processors, different generations, different varieties within a generation, some of them support different extensions to the instruction set than others. It's not as simple as just saying, oh, this is an x86 instruction or not. Like, it may be gibberish to a certain CPU and not to a different one. So from one perspective, you really just want to figure out what are the instructions that are possible on, let's say, the CPU that I have in my computer right now. Some AMD CPU from, like, I don't know, Zen 2, I think. Maybe, yeah, I don't think it's Zen 2 Plus. So given that, he came up with and given the fact that there might be instructions that are simply not mentioned in the manual, that might be, you can call them secret, but otherwise, they're not published instructions that are in the list in our PDF that we have. He came up with a program that sort of fuzzes the CPU, trying to figure out if the processor recognizes that instruction. And he's able to, and he does a lot of cool tricks to get the processor to tell his programmer, sort of tell him what it thinks the length of a particular instruction is based on the bytes that he has provided it. And that way, he's searching through the potential space of instructions in a much faster manner than just brute force, start at 0 and then go to 0.1 and 0.2, etc., up through 15 bytes or something. That would simply take too long. But yeah, so he does a lot of neat stuff, and he's worked out, a lot of the potential instructions that you could have. So my thinking is, if he's got this result that can show what all the instructions are, why don't we use that to get ourselves a list of instructions to try to use as our, essentially our test cases. But in this initial work, it's just going to be, what are the instructions that I want to focus on being able to decode. And then, if things get really go well with this project and I want to make it more complete, I think using the results from this is a guy from Intel has written a fuzzer to find undocumented instructions. I don't know if he is from Intel. You might be mishearing. Earlier I said that the project was forked from Battelle. Maybe he works for Intel now. I guess that could be the case. But I don't know that he worked for them back then. We could find it on LinkedIn because that was 2017. Yeah, I think he ended up getting hired by Intel after he did this project. He was working for Battelle, which is a sort of government contractor company in the U.S. At the time that he worked on this thing. And I don't know, I guess they just had general purpose R&D that he was working on, which is interesting. Okay, so yeah, I mean, even still, you are probably right that there's probably folks at Intel that would need to use this program to find out what all the instructions are, because they might not have those in a manual that's just go on the internal wiki and now you get all the secret details of it. So okay, so I would, I think this would be a good use for test cases, especially if I decided, hey, I want to write a decoder that is like as complete as possible and as free of incorrect results and missing results, sort of false negative kind of things where it's like that's not an instruction, actually it is. But again, that's sort of down the line. So what I'm hoping for is, it's looking like there probably is not actually not necessarily just like pre-built results of a list of instructions. So I might have to do, download this and run it myself, I guess. Okay, that's fine. So yeah, what I'm gonna do is download it, run it myself, and see if can we tell it to only give me single byte instructions. Number of base instruction bytes in each subrange. Oh, even just that description of that is like, I don't know what they mean by subrange. So all right, well, I'm gonna do the incredibly secure thing of downloading a piece of software from the internet and then maybe running it as sudo, since it says that the best thing to do is to run it as sudo. Yeah, so we'll go ahead and clone this. Oh, cool. Gonna deal with this off screen. Okay. So to run a basic audit, I don't want to really do the audit stuff. So we have unknown. Don't want to do that. Don't care about unknown instructions for my use case. Why not write it directly in Rust? So my theory there, or my thinking on that is, I don't know Rust almost at all right now, and I don't know how to write this program. So if I attempt to take on a project that is both do a thing in a like that I don't know how to do and do it in a language that I don't know, I'm going to be compounding the difficulty, and just making it that much harder for me to make progress and continue, you know, having like a good pace of progress, I guess. I don't know how to put it, but I've found that when I have tried such a thing before, where I'm like, hey, I want to learn this new language, and I want to do it and I want to work on a project that I don't know how to make that, like, I don't know what code I need for that project because it's, I'm trying a new thing. It's not worked out very well for me. So I want to do the thing first and then redo it in Rust, basically. The low-level programming stuff is not that different in C and Rust. That is probably true, I'm assuming. I mean, there's definitely a lot of niceties that I have seen from when I've watched people code in Rust in terms of, building structures and traits that work on those structures. Like, there's definitely a lot of nice things that I won't have in the C code. But hopefully this program is small enough that it's not going to be held back by that too much. I mean, realistically, decode is the one function that my API needs, and there might be, a handful of helper functions to make that work, and break it up so that it's a little more understandable than writing it all in one giant function. But really, I think where Rust would be most useful is like in being able to, I don't know. I mean, there's not necessarily even that much difference for this purpose because the data structure, whatever it's going to be, is going to be very simple. In terms of, I think there'd probably be a unique ID to represent the instruction. So like my thinking right now is the data structure for any given instruction is, yeah, again, yeah. I would like to do it for a more, make use of this program eventually, but gonna have to do the education style version first, I think. And then the thing that I need to really get better at, even though I've told myself this a lot and I've tried to tell students of mine or other people learning programming, is be willing to throw away the code that you work on. So whatever code I'm writing for this project is going to get thrown away because it's not like, I'm going to rewrite it in Rust, but even that probably will get thrown away because I think I have other ideas for how I would like to structure this, but at the same time, I don't know how to write the core of the thing. So I'm not going to also take on trying to structure it in a unique kind of way. Without knowing how to do the core. So there's going to be several iterations of this project, assuming things go really well and I keep being interested in working on the decoder stuff. There will probably be multiple iterations that I end up throwing away just because I don't need to keep around or, stay tied to a version of it that made sense to me when I didn't know anything about what the solution was, so to speak. I imagine so one of the people that, if you haven't watched him on Twitch, there's a guy, Gamozo. He does a lot of Rust programming. He's really good at it. I love watching his stream because he's, in my opinion, an extremely good programmer. He's written several hypervisor projects for different purposes, usually related to fuzzing stuff, but I think each one probably has a different sort of specific goal that he has in mind when he's working on it. And I assume there's several hypervisor versions that he worked on, years ago that he's since thrown away because it doesn't matter because he can just write another one for the purposes of the thing that he's focused on in this case. And obviously there's a level of program that you can get to where it doesn't make sense to necessarily throw it away. Like, you're not going to throw away an entire web browser that has a JavaScript engine and all of that and just rewrite another one of it because it's, that's too big. But something like this, I don't think it would be crazy for me to write 3 or 4 different implementations and throw the first 3 away. Yeah, I mean, maybe it's, again, I don't have it like a particularly specific use for it. other than it's something that just keeps showing up in my brain of like, hey, you should write a decoder. Hey, you should, make a decoder that works this way rather than the way that a lot of decoders work, that kind of thing. So if anything, it's still, in the realm of practicing. And maybe it'll get to a point where I'm like, hey, I have a really good use case for this now, but I don't expect that with the initial versions of this that I'm working on. So, what was it? Okay, so what I was thinking for the data structure result. So if we decode a single instruction, what is the actual piece of data that we will then output to represent it? Because I don't want to go directly to a string version, like disassembling into a mnemonic and the string versions of the operands for it. My view is that that's could be done with some additional processing afterwards, after the fact, depending on what you need out of it, basically. So as an initial thought, I'm thinking like, okay, this instruction would have a particular unique ID. This one would have a different unique ID. This one and this one would have unique IDs because they're all technically different instructions. Even though these have the exact same byte encoding, and it depends on whether or not you are in 32-bit or 16-bit memory or mode on the processor, maybe these can't have different unique. I mean, in theory, you could have you could uniquely distinguish between these two. It just, as a decoder, you wouldn't really have the knowledge to know which of the two you have decoded, because there's no CPU that you're emulating. There's no additional layer of static analysis like in a disassembler that would be able to tell you, hey, right now we're in 16-bit mode. That being said, you could pass a flag in or something like decode these instructions as though we're in real mode or whatever it is. And so you would get a unique one for this one and this one. But that's the general theme, is like, okay, let's do like a 4-bit integer and have that be, a 4-byte integer, and use that as an enum, basically, where each variant of any given instruction has its own unique number. And that's certainly partially the case with the way that it's encoded, but it's just not as accessible as having it as like its own 4-byte chunk that can be referenced, because it's wrapped up with the pieces that represent the operands and stuff of that nature. So I would have that, and then there might be 3 more bytes or 3 more integers, maybe, depending on how many operands you have. And it would just, depending on what the opcode enum value is, we're using 0, 1, 2, or all 3 of those additional bytes in the structure. That's my first guess. Maybe, and again, this is, would only support 32-bit. And I don't know, maybe that's not even enough, because your memory operand, at least on 32-bit, I think could be any value, any 32-bit value. Whereas with 64-bit, I think you're limited to canonical addresses, so you could actually make use of those couple of bits that you have at the high end of the quad word, and use that to represent registers instead. I don't know. But that may not be possible with 32-bit operands. So, and well, but at the same time, maybe, if that we're using, so if we had a unique value in the enum for the version of this 89-byte where we have a move for a memory instruction or a memory operand, versus the one where it's like register to memory versus register to register, if those are different enum values for the opcode, technically they're both moves, but they're different varieties of move, then we know that this, the first operand and the second operand are, in the first case, one is a memory address, the second is a registered identifier, and in the second case, we know that they're both register identifiers. So I guess that's how I'll go with it. Like, we'll basically decode each instruction into into 16 bytes. It's pretty large, but that's kind of the point, is we aren't trying to have it as a very compressed representation of the instruction stream. And just, some of those bytes aren't going to be used. And in a lot of cases, it'll be too much space for how much we actually ended up needing. If we're talking about a register, we don't need 4 bytes to represent which register that we are working with, but that's fine. So that is my thought right now. I give it a 30% chance that actually plays out as like how I end up using the data structure, or what data structure I end up using, and more of a 70% chance that there's some caveats in there that I am not thinking of. Immediate values, again, if we're only talking 32 bits, then those could fit into one of those 32-bit operand values in the data structure, so that seems fine. moffs 8 is, I don't know, memory offset 8 or something. Like, hopefully all the different variants that I am not thinking about in terms of operands and what they could be. We've got segment and offset. I think those could probably still be encoded in 4 bytes. It's just more annoying now. You have to like represent, you're going to encode both of those inside of the same integer, I guess. Or you could do a union. We could like get complicated with it. So I think that's the structure that I'm going to go for. And what we want to do is again, we want to like give me the list of single byte x86 instructions. Maybe I can just search for it. Well, here's one. Okay. So this might be more useful than actually going directly to the sand sifter stuff. I guess, doing the mnemonic stuff would be helpful from the standpoint of being able to visually, manually inspect the results, rather than just setting up test cases, which I haven't even like gotten a test library to use to set up test cases, but I think that's probably what I'll end up doing. Maybe off stream, just get that out of the way. Offset opcode prefixes. These are like single byte prefixes to other instructions. I don't care about that. Okay, interesting how this is structured. So these are instructions that are 1 byte total. Yeah. Okay. So what we were talking about before with the exchange instruction, exchange, EAX, and some register. The way they're writing this is a little more sensible to me, or at least, I can understand it a little bit better. We've got these upper 5 bits, and then the lowest 3 bits in the byte are representing the register itself. So if they're all zeros, then I guess that means we're talking about EAX. Is that accurate? Yeah, because this will be 9. And 0. Okay. So, I mean, we could start with that. I guess the other thing is like how to develop that enum list where we have a unique value for each one of the variety of instructions. But no better way than that I can think of right now than just to like start manually putting stuff in there. And then I think, we'll just have it be able to decode some of these instructions. So I guess this is the simplest instruction, right? It's got no operands. It's got no different pieces to it. So push A and pop A are single byte, no other variety to them kind of instructions. There's push A D. I guess that's just the D word. So if we're in 32-bit mode, they'll call it push AD. Okay. Yeah, this would be the simplest instruction, but again, is not like particularly helpful if I write code that only that is hard coded to decode this stuff. I think what I want to be looking at is basically take the first. Why is it that? Okay, they're just leaving off the high 0, I guess. But we want to. Is my math wrong? That's just 7, right? Yeah. So we take the high 5 bits out of the byte. We use that to figure out what category of instruction we're talking about. That logic is probably too simple to work for later situations where we start needing to be able to work with multi-byte instructions and we have to figure out prefixes and stuff. But all of those are going to be some encoding of those 5 bits that are not one of the ones that represents a single byte instruction, I guess. That's my assumption right now. So if we pull out those first 5 bits and then we match it against some table that has the particular ones where the low 3 bits are a particular register that we're referencing, then think we can go from there, basically. And the C, like the convert stuff, is I guess technically single byte because it's hard coded to use a particular register. So, okay. But it looks like, just browsing through these, we have instructions that either work on you're right, they happen to be encoded exactly the same, but I think technically Intel considers this a different instruction. It's just sort of hypothetically a different instruction. There's no true difference there. And I think for my decoder, I would say we will decode it as though it were the exchange EAX, and some further layer in processing that would use the results from this decoder would decide, okay, let's represent that as a NOP. I think I'm okay with that, and maybe we just will skip NOP as a particular instruction enum. I don't know how often this kind of circumstance comes up where you have, other than a slightly different mnemonic like a JNE versus a JNZ or something. I don't know if you have what are technically two different instructions that are semantically the same and are encoded as the exact same bits. It might just be these two, which is my hope, because I think the simplest thing is to say, let's ignore this one then, and consider that a problem for some other software to decide about. They would just consider exchange EAX as represented by my data structure to be NOP, and that's fine. But otherwise, I think what we're looking at is each of the upper 5 bits, these two, and all other multi-byte NOP variants. Yeah, okay, I see what you're saying. So like when we looked at NOP earlier, because there are these, or I guess technically it's the same bytes for 16 and 30. So this one is probably also the same as some other instruction, which semantically is a NOP. Because I know there are multi-byte NOPs that do a thing that is semantically a NOP, but I don't think that Intel lists those in their manual as being NOP. They're just like, hey, if you did this, it wouldn't change anything. Kind of like coincidences, I guess. I don't know. This is probably like a meaningless distinction, or a distinction without a difference, or whatever they say. Like, yeah. So we're going to decode it as the most specific sort of non-NOP instruction possible, and leave the determination as to how to represent that to a user or some other consumer of these results. We'll leave that up to somebody else, because I don't want to deal with it in this program. I don't feel like it's going to help me learn anything to make that determination, I guess. So again, what I'm seeing is, well, okay, so we've got these situations where we'll have the first 5 bits, and then the remaining 3 bits still determines what the instruction is. These are all about flags, so in some sense, I don't think it's as regular as being able to look at the first 5 bits and then use the remaining 3 bits to determine what flag we're talking about, because like this has all ones for the first 5 bits and it's setting a thing, whereas this has all ones and it's clearing a thing. So I'm going to go with, once we get into this category, we have a set of instructions that, you know, depending on exactly what the upper 5 bits are, we then need to additionally look at the remaining 3 bits to determine, it sort of works out to being the same. No, it doesn't work out to being the same, because this will have a different enum number, but it won't necessarily have anything in operands. Whereas the ones up here, we'll have a particular enum number for the instruction, but we'll also have a value in the first operand portion of the data structure, because that'll be the piece that has what register we're talking about. So okay, Yeah, I'm just sort of playing this out in my head and seeing all the ways in which this is going to get more annoying than I would like. So, like, presumably the decrement instruction, let's say, has, if we have 000, we're talking about AX in 16-bit mode, but we're talking about EAX in 32-bit mode. And if I want those to be different enum values so that we can technically distinguish between a 16-bit version of decrement and a 32-bit version of decrement, am I going to be hard coding? Like, am I going to have an if statement that then decides one enum versus the other? Or am I going to be adding a value to the enum and just know that I've encoded the sequence in the enum as like dec 16-bit is one below dec 32-bit? I don't know. I don't know if that makes any sense to y'all, because it might just be based on what I am imagining in my head right now about what the structure will be. But gonna give it a shot. We're gonna, I guess, work on push A, which is actually very similar to the flag stuff because we've got the same upper 5 bits. So yeah, okay. Let's okay, how do I want to do this? There's definitely, I don't know if this would be easier in Rust, but there's definitely some things that could be done in C++, or with some sort of extended C++, let's say, that I've seen. I don't remember the names of the libraries that I was looking at. It was data. Oh, what was it called? I think I have the article still somewhere in another tab. I was watching a video by this guy, I believe, with this Datadesk program. And by program, I mean it's like, it's more of a library that you can include in your code. And it allows you to specify data structures in a certain DSL, essentially, and then work with them in C or C++ and get a lot of niceties out of that. So this is where I might go after today's stream, when I start having a bunch of these enums. But basically the idea would be I want to have code that is just automatically going to be able to print out the name associated with a particular enum value. Doesn't instruction decoding depend not only on the mode the CPU is in, but also on memory page attributes and possibly MTRR? I need to refresh myself on MTRR, what that means. I've definitely seen it before, but it doesn't ring a bell right now. So like, oh, memory type range register? I don't know. I mean, there might be instructions where the decoding depends on the state of this stuff. I would think, like, this is determining the mode for how memory is being written and whether, we are caching it or not. I wouldn't think that the instructions would be decoded differently. They would, the actual execution of those instructions would come out differently as a result, but it doesn't make a lot of sense to me that they would consider it a different instruction, at least from the level that I'm talking about. It being considered a different instruction and maybe mapping to a completely different set of microcode instructions or whatever happens actually inside of one of these CPUs certainly seems reasonable. that like there's a lot of other factors that come into play when the CPU does its decoding work, or some stage in the decoding pipeline has to then take into account some of these things. And then memory page attributes, like, I don't know if you can tell me an example of a scenario where you think that might come into the decoding. I'd be curious. I don't have any reason to say it definitely doesn't, but it's not something that I've had to think about when I've looked at like instruction. Like, those seem like things that would prevent you from being able to statically decode and disassemble a program, because you would need some information from the dynamic process of running it, or you'd have to simulate that through eventually some level of what you call it, symbolic analysis kind of stuff, where you're simulating how the CPU would work if some previous instruction had set this memory range. But especially with like what the like page table entries have and what the permissions settings are. Maybe that's not actually what you mean by memory page attributes, but I was thinking like the permissions available on any given page, or range of pages, or whatever is stored in the page table entries. Page table attributes, I don't know. Oh, maybe it's different. It's not necessarily like read, write, execute permission kind of stuff, but also how that stuff is cached and all that. So yeah, I mean, that stuff I do not know at this point, but I feel like basically I don't think the disassembler that I use, which doesn't do any particularly fancy simulation of the CPU when it's doing its disassembly work, I don't think it's running into any problems of not being able to understand how that instruction decodes, because it doesn't have that info. But yeah, very curious if you do find an example. For now, I'm going to not think about that. And it simply might be an incorrect result that I get. So yeah, with Datadesk, I think a nice result, I don't think it's shown in here, but like if I had an enum like this, I think I could I think I could put some kind of markup on this and get the ability to just print it. And so if I had a value from test enum, I could have it print out enum 1, 2, 3, or max, whatever, based on what the actual value of that variable was. The Cybermentee, hi, how's it going, man? Thanks for the follow the other day, a couple weeks ago, I guess, or yeah, basically a couple weeks ago at this point. In theory, I'm working on coding tools. I haven't done a lot of coding thus far on the stream, but I've been sort of circling around that. So right now I was just thinking about going forward as I build up this enum with all these different instruction types, and then I want to be able to, for simple test cases where I just want to print it out to standard out and I can look at it myself and verify the behavior is correct. I want to be able to easily print these enum values rather than manually go through and write a bunch of code that like figures out and prints the enum value with I don't know, a big if statement or an index into a table of strings or whatever. But for now, I'm not going to worry about that, because I'm not going to have many instructions that we're going to decode, that we're going to be able to decode on this stream. So we'll start with push A, which again basically requires looking at all 8 bits. And based on knowing what the upper 5 bits are, technically it's these, with the zero, a 0 in front, then we can determine that it's either a push or a pop in the low 3 bits. Like, I don't know if that's a distinction that's worth making in this case. It just feels like the right way to go because there's so many instructions where the low 3 bits are the register value if it's an instruction that has a register operand. So we'll just start with that, I guess. Let's name it IXNs because it's in theory multiple instructions. And why don't we use better types as well? Okay, so we're going to get the first byte from our instruction stream. Right now we're assuming everything is 1 byte. And I imagine as we add multi-byte stuff, we're going to have to figure that out by looking at the first byte in any case. So we'll pull off the first byte from our pointer to a stream of instruction bytes. And we're just going to let's do we're going to shift off the lowest 3 bits and use that as the opcode. Can I do this? How do I this is going to be a terrible search. We'll see. Binary predicate? No, it's not a predicate. Oh, like a prefix. Whoops, that's not how you spell hexadecimal. Okay. Integer literal. How can I do binary? That's only in. Do they have the info for C? Can I go ahead and do that? I guess we can give it a shot and see if the compiler is open to it. You can't do this in C. Right. Yeah, what? I mean, you know, we'll find out, right? Why don't we go ahead and do that? I don't think I need to fill it out entirely. What did I do wrong here? Unused? Sure. Also unused. Okay. Pointless. Oh, yeah, of course, because it's the definition. Whatever. Just, okay. It seemed to like it. It was fine with it. Do I work in InfoSec? I do not. I don't really work anywhere right now. I am technically a student at a self-defense course here in Thailand, where I'm staying for this year, before maybe going back to the United States and maybe getting a job in InfoSec. But I'm, just sort of practicing my skills, trying to keep up with programming, which I've done for a while, and move into more hacking related work. Maybe go back to the game industry. I don't know. I have a lot of mixed feelings about the industry, and I would end up being very picky about where I would end up working, I think. But right now, the focus on low-level stuff and hacking, kind of, sort of using my understanding of low-level stuff to try to subvert the intended behavior of programs, that kind of thing, is really interesting to me. So I'm trying not to think too hard about what this turns into career-wise, and just focusing on what I find interesting so that I can keep up my motivation to work on it. Because I think the more I get focused on, like, oh, can I get a job from this? Oh, am I going to have money from these skills? Is this going to turn in, pay off for me in some way? Is actually not very motivating for myself. And so I want to focus on what keeps me motivated, because then I will do better at learning the stuff. And in theory, if I know more stuff, if I learn more stuff, then that translates into being able to use those skills more successfully in, I guess, a career or, self sustenance kind of way. I don't know what I'm saying. I'm kind of rambling at this point, but just like, I'm trying not to put the focus of how will this turn into a job as my first thought process, and instead have that follow what I'm doing. I'll do the thing that I really like and then figure out how to turn that into a job, I guess. Which, I'm in a very lucky position to be able to do that. But of course, I can only do that so far before it just turns into, oh, well, I need any kind of job so that I can afford rent. You're trying to transition yourself from being sysadmin/systems engineer and want to do more security related stuff. Awesome. That sounds really cool. I think, more people being interested in doing the security related stuff is a good thing, because it doesn't seem as common that people want to look at this side of things. And it, at least from my standpoint, and I come more from the like software developer end of things, and the pieces of security/infosec that I am most attracted to are probably the pieces that relate most to software development. So maybe like reverse engineering and just, low-level binary kind of stuff. The sense that I get from everything that I've learned is that they are really like two halves of the same coin. Creating the code and breaking the code are like highly interconnected. And I think that probably applies on the sysadmin kind of end of things, where building a system, setting it up, configuring it, and then also seeing how that system can be broken into, how the configuration is not adequate from a security standpoint or other standpoints. They are like meshed together, married together pretty closely. So it's a little bit sad to me that there's so much focus on the like build side of things and not the break side of things, because knowing both of them makes you better at the other, in my viewpoint at least. And I just think it's like, at least what I see from software development, and I imagine it's also the same in sysadmin work, is that there's the market forces kind of, it's such a strong focus on make more stuff, produce more stuff constantly, write code as quickly as you can, get it out there as quickly as you can. So all of the focus is on building and not on being able to determine if what you've built is broken. Only determine that insofar as it breaking is like a detriment to the bottom line. And security stuff is a risk assessment kind of thing rather than a we can't make any money because there's a security flaw kind of thing is usually the case. So capitalism is not a very good motivator for investing in stuff like security, but it is important. So it's great to see people that have that sort of mindset and want to look at that, even if it's not where companies want to, put all of their money, I guess, so to speak. And a lot of that is pontificating on my point, because again, I haven't worked in InfoSec. It's just a bit of what I have noticed and extrapolated from, and what I've heard from a lot of people that do work in InfoSec, is it's constantly feels like you're fighting against the will of the company when you are bringing up the fact that, hey, this thing has problems. Do a lot of development yourself? Nice. Work at a small VFX studio. Awesome. Yeah, I mean, I worked a little bit in video games, and obviously there's a certain amount of like crossover there. And I'm a huge fan of like the working in those interdisciplinary teams with artists and programmers, and it's just a lot of fun to be able to have all these people that have completely different skills that are still all focused on the same goal and are united in that focus, and like everybody bringing their own skill set to bear on the problem. That was what I loved most about working on games, for sure. And having to do loads of different stuff and looking through some of the artist code for pipeline tools, etc. Nice. It's mostly hacky ways to get a thing to work without paying attention to what can go wrong. Yeah, I imagine like from a security standpoint, a VFX studio is probably, supposing you can get in to the internal elements, like the code that gets written and run on these various machines is, at least as bad as what it looks like on a software development studio. From like, people talk about pipeline based, or what is it called? I guess pipeline maybe is the term. I think maybe there's a different term that's the right one, but the idea of like, hey, if I'm writing a JavaScript program, I'm going to run npm and install a bunch of stuff, and then I'm just going to run that code on my computer. Like, you don't really need to find a buffer overflow to get RCE from that. You just need to get access to the chain of whatever determines what code gets downloaded to my computer, because I'm not going to look at every line of code that I've downloaded with npm and make sure that it's not got a backdoor in it. So those sorts of attacks, what is it? Supply chain attacks, I think is the term. I imagine VFX Studio is the exact same kind of situation as that for a software development studio. Like, ultimately part of your job, if you're doing art development that requires any sort of technical artist kind of work, where they're throwing in a little bit of code to do programmatic stuff, programmatic generation of stuff, whatever it is. Basically, part of your job is to run code, and you aren't necessarily going to have the time to audit all of the code that you run. Hopefully, you're getting it from a trusted source, but if somebody gets into, and makes that source no longer trustworthy through whatever means, then your machine is very open to that. So yeah. And I also imagine that a VFX studio is not the kind of company that's going to want to put money into security. They're going to have the mindset of like, well, really, who would hack into our stuff? Except, maybe if you are like, what is it? ILM or something, one of these really big companies that is working on a movie that, there's some friggin' fanboy out there who's like, oh, I gotta get I'll be so famous if I hack into there and get some shots from the, whatever in progress work on the next Star Wars is or something. But I think a lot of game companies that aren't Valve or whatever don't really think about it in terms of, oh, is somebody going to hack in and try to steal our source code and release it? Maybe a lot of them started thinking about it more after Valve got hacked in 2004 and then again recently, but I think for the most part that doesn't come up. Which, surprisingly, I think is the same logic that a lot of companies go on, is just like, we don't have stuff that people would want to hack in and get. But, hard to say if that's actually the case. And with the prevalence of ransomware, it doesn't really matter if you have stuff that other people want. You have stuff that you want, and if they can take it from you, they might be able to make you pay for it. Working with ILM on projects from time to time, so we have very strict security audits. Yeah, I can imagine once you get into working with a company, like that, they're like, I guess ILM is owned by Disney at this point, and Disney, takes their shit very seriously, and they do a pen test cert paid by the company ATM. Yeah, that makes sense. So. That would be cool. I don't know if you've had a chance to talk with the pen testers that have come in to audit, but I think they would be, depending on if they have time to talk. I don't know what they're, how frantic it is when you're on one of these tests, and if they're even I guess if it's not like a red team kind of simulation, then they're probably, I don't know, they're probably not on site. But this is all, again, way outside of my knowledge base. I've listened to some podcasts where they, interview people that have done maybe more red team style pen tests and stuff, but I don't know how those things go really. But if you can talk to them, if you get that chance, I think that seems like a good opportunity to get a little more random individual feel for what their day-to-day work is. Talk to people on Twitter and all that, and obviously tons of stuff to watch on Twitch where people are doing that kind of work. And I think over the weekend I'm going to try to work on Try Hack Me stuff. Oh, nice. So they're actually interested in having you be certified. I misread what you meant by actually doing a pen test cert paid by the company. I thought you meant they've paid a company to come in to do a pen test to certify something for ILM's needs or whatever. That's awesome that they're paying for you to go get whatever the cert is. What is the certification? We'll get back to this a little bit. Just leave it there, I guess. Is that? Yeah. eLearn security. Okay. I haven't heard about that one. But hopefully it gives you, a good sort of framework and goal for learning more stuff about pen testing. My sense, if it's anything like what I was talking about with the trade-off between software dev and reverse engineering, is all of your knowledge about system administration is going to help you along that, or maybe you've already seen it help you with that. And so good on you, man. Okay. No, we want 8, or God, I'm terrible at this. 3 bits. It's gonna be 7. Yeah. Then, hey Julian, how's it going? You missed a stream that I was doing yesterday where I did a little more binary exploitation work. Today I'm doing a little bit of coding on working on a x86 decoder to try to get more understanding of how the x86 instruction set is represented in the actual, binary machine code representation. And just super early work on that right now. Basically, I'm working on seeing if I can get it to decode the push A and pop A instructions, because those are some of the simplest that are possible. They have no operands or anything, so it's a very straightforward see about, is it this exact 8 bits or not? And we'll go from there. And then tomorrow I'm going to go back and do more binary exploitation work. I've put up a schedule, so if you want to check the schedule tab, I'm going to do like Monday, Wednesday, Friday binary exploitation, Tuesday, Thursday working on the software project, this particular project right now. And then on the weekends, I think I'm going to try to do try-hack-me stuff. I just want to switch it up because I've been doing like the same Nightmare Core stuff every single stream before I took a break. And I think this will help me out a bit, because like I got to the point where I kept thinking like, oh, I'd like to work on the decoder project, and kept putting it off because I was, let me just go back to doing binary exploitation. So I'm just going to have a schedule where I vary it up, basically. Let's see. So if we get the low 3 bits from the instruction and that is non-zero, then it is a push A instruction. What do we want to do here? In code segment descriptors, the D bit selects the default operand size and address sizes. In legacy mode, when D equals 0, the default operand size and address size is 16 bits, and when D equals 1, the default operand size and address size is 32-bit rather. Interesting. Okay, so when they say legacy mode, is that the same as real mode, or is there a difference between those modes? So obviously it's a mode in which you have segment descriptors, which, I mean, technically 32-bit, like what might be considered normal mode, I don't remember the terminology, does have actual non-zero values for the segment, what do they call them, selectors, as opposed to 64-bit, which like officially makes them not a thing. But the segment descriptors, which are basically like a model specific register, I guess, a particular flavor of model specific register. So for the code segment, it's going to look at That's interesting. Just adds another layer of so legacy mode includes protected as well as real. Okay. Um hmm. I have just never seen that come up, I guess, or at least like, I mean, I don't know how it would be exposed to me when I'm looking at the instructions that I'm seeing from the disassembly tool, because they would basically have to say, hey, here's one interpretation of this instruction stream if we have a code segment where the D bit in the descriptor is 0, and here's the interpretation if the D bit is 1. So, maybe they just assume that the D bit is 1. And, if I tell it, hey, read this as protected mode, like non-real mode, 32-bit instructions, I don't know. I mean, I'm sort of like mashing together some concepts when I say it that way. But, maybe it all comes down to how I have told the disassembler to interpret the program. And if somebody wanted to, if you're writing a malware or just some kind of tricky software that's intended to mess up disassembly and mess up the reversing, then you could switch between that stuff and like set the descriptor, and in the same way that like ARM whatchamacallit, like switching to thumb mode or not is going to determine how you need to disassemble the instructions following it. Yeah, I'll keep that in mind as a like, is there a way to factor that into the code that I'm working on? Cybermentee, at what time do you normally stream? So previously I was streaming somewhere around 12 hours prior to right now. Would be like around when I started my stream. I was doing it, which is basically the morning where I'm at. And I've decided to maybe switch it to doing these evening times. So that's also on the schedule. It's basically let's see, like 11 a.m. GMT, I think, because it's GMT plus 7, or no, sorry, 1 p.m. GMT. But yeah, I think if you look at the schedule page, it should show it to you in your own time zone. So that's when I plan to be streaming from here on out, just because I think that might be more accessible to folks, rather than like I was starting, it was like midnight on the East Coast in the US when I would do my streams, and probably just doesn't have that many people watching. And then obviously it's even later in Europe and the rest of Asia. So yeah. Cool. Thanks for tuning in today, man, and hope to see you tomorrow, or whenever you can pop back in. Happy to have you in chat. Thanks for watching. And so yeah, I'll try to keep that in mind about the fact that there's little bits of state that I don't have access to, which might influence how these instructions get decoded, at least in terms of like the operand sizes here. So that might need to be a flag that you can pass to the program and say, hey, interpret this sequence as that. Obviously it doesn't help if that bit changes in the middle of the instruction sequence. So if you have something that sets that some opcode, I assume there is some, I don't know what they are, but like if it sets the segment descriptor bit D, then I'm not going to go through the work of being able to recognize that and then modify how the remainder of those instructions are decoded. I think I'm going to set that aside, but it might be possible for me to have a flag that you send to the program that says, hey, interpret them as though this bit is on or off. Because, yeah, so thanks for looking that up and finding that, because that is completely new to me. I don't really know that much about the segmented stuff. I barely understand, like, I understand the concept of the segmented addressing mode. I don't know the details of it. I'm probably going to have to learn it while going through this process. But I definitely don't know all the details of like what gets thrown in the segment descriptors. I had never heard of this D-bit. So I'll have to look into that more too. Okay, so we're gonna have to define the data type that we actually want. We'll leave the enum, I guess, for right now. And do this as push A, pop A. Why do you gotta be like that? Emacs. Alright, whatever. And we're gonna call all this. Gonna call this one instruction. So it's gonna have an opcode T or an opcode, and do we want a 0 index? We'll just do this here. Okay, so memory allocation. How do I want to deal with memory allocation? Because there's going to be 16 bytes. Do I want to just straight up copy 16 bytes? No. We're going to take it as... Ugh, my naming is terrible. Just do void for now. There might be a good case for having like an error code result. But again, like as pointed out, this program is a little bit useless, so that makes it harder to make some of the decisions required when writing code, because do I return an error from this? Well, that sort of depends on how this code would be used. And if nothing is using this code, then knowing whether I want to return an error or not becomes kind of difficult, or at least arbitrary. So we can say, oops, we do it like this. Dot opcode equals if it's a 1-bit, that's a pop A. Okay. And that's all we need, I guess. Everything else is 0. Now, this, might be incorrect. Why am I blind? Like, why is there not a 0 ahead of this? But, all right, let's see if no, okay, that's different. It's different because there's 4 bits. Yeah, see now, but these are the prefixes. Okay, so there are some bytes. Am I making a VM? Hi Jay, I am not making a VM. I am making one very small piece of, I mean, I guess in theory you could use this in a VM, but you probably wouldn't. I'm making a program called that decodes x86 instructions. So it takes the binary representation that would actually be sent to the CPU or a VM, that is emulating that CPU, and converts them into a data structure that could be used by a variety of static analysis tools like a disassembler, something that checks for bugs of some sort, any sort of binary analysis work, I guess you could use it for. Ultimately, a decompiler as well. Right now, I'm using it just as a learning tool to learn the x86 encoding format, and just to sort of play around and maybe eventually use it as a tool for learning Rust if I want to convert this code into Rust code. What have I done wrong here? Can I not initialize it with that structure? Well, let's go. We will assume that it has been okay, and then whatever. We're gonna just like early exit for everything right now, and I'll have to come back and write real error messages and all that. But for now, we're gonna say dot opcode equals pop-a. Does that work? Oh, I can just do it this way, right? Yeah. My intensely good C coding skills on display right now. We'll just return here. We could write this as a ternary. Do I want to do it that way? Why not? Don't really need the parens there. Okay, so in theory, this can decode single instructions for either push A or pop A. So let's say we have $60 and $61. Got a sequence of those, and And we're just going to make a loop with these. So we'll say is the right way to do that? I feel like that is. What do I want to do for so we don't have a null byte here because null is a valid instruction. It's not a particularly meaningful instruction, but it is technically an x86 instruction. So I don't want to end this with a null byte. I want to terminate it like a string. Oh yeah. I'm doing this all wrong because it's now uint and not unsigned char. 61. Let me do this. What have I done wrong here? Let me just do it as an array then, and then I can do size of. Alright, just do it this way for now. And maybe later I will make something that reads from a file, or I don't know what. So test one. And we're just going to do decode on test one, and then we want actually a uint pointer to and just increment it now. Oh, that's what we could do. And all right, this is ugly, but we do it not as a for loop then. Okay, so let's see about what this is doing. We initialize a 0 filled instruction structure. Then we have a pointer to the beginning of our array of actual instructions. We get the size of that array since it's fixed and we know it at compile time. And we'll have to figure this out at some later point when we don't necessarily know the size at compile time. I'm going to worry about that later. Then as long as our pointer is less than the start of the array plus n, this is probably dumb to be doing pointer math like this, but I think that'll work. We'll find out, I guess, if it crashes. Then we'll go ahead and decode one instruction from it, putting the data into the instruction structure that we have on the stack. And we'll get back the size of that instruction, which in this case is always going to be 1. And if we didn't decode the instruction properly, we're just going to abort. And we'll dealing better with error scenarios will come in a later situation. And then we'll add that to our pointer, and we'll just keep looping until we get to the end of the array. We'll see. So what do I want to do with this now? I want to really need to make sure that I'm more consistent with where I put the asterisks for the pointers. I feel like when I do C++ coding, I like to put them like in the opposite way, like this, because it still feels like this is the type. I don't know. I don't know why I have a different preference in C++ code versus C code, but there you have it. All right, so just gonna do this one. Make that real simple. What's going on here? Oh, okay, yeah. Case, push A. We will need to include all right, then we will go ahead and print that instruction object. And we'll be done. Okay, so in theory, this should print out, what is it? Pop A, push A, pop A, push A, push A. Pretty sure. Nope, it crashes, so my coding skills are top-notch. Did I not? No. Go ahead and make this debug. We got abort. Okay. Okay. We want Yeah. Okay, we were in decode. What did we get? We got something that was not... Interesting. Maybe my thought process on this is wrong. Oh, I don't have... So sad that I don't have GDB set up properly. Let's go ahead and fix that real quick. I've been using GDB in a VM for doing all of my exploit development stuff, and have not bothered to fix it, don't do anything with it on my host machine, which is what I'm developing on right now. All right, so don't I have source code? Can I don't like, I'm so bad at GDB when I actually have source code. Let's see. I don't know what the right, like, no, I don't want a PDF. There we go. So let's see if we can print a function, list decode. Okay. So can you not give me the next? 21 through, so I guess I can just say like break in x86 deck.c on line 27. That's the beginning of our switch. So we shall have figured out what our variable that should represent the opcode is, what we're actually switching upon. And we'll see how that plays out. Maybe this part is wrong. Like maybe that's not the prefix for it, but it sure seemed like it. Again, these are the low 3 bits, then we have 4 bits, and I can only assume there's a 0 up here. Because, no, wait a second, that would make this, okay, they're missing a, where is the missing 0 in this? What am I, like, this is 7 bits, right? But the upper 4 have to be this, because that's what'll be 6. So they're missing a bit at the bottom? How would, like, who would write this? I don't understand why you would drop a bit here. Or, I mean, it's not even dropped here, it's like dropped from the middle, because the 001 here maps to the 1 here, right? Like 61 is going to be 0110 0001, pretty sure. How do we do that? I'm just gonna do it in this. So we definitely have 0001 and then 0110. So yeah, I'm very confused at how they have chosen to represent this. Not a problem though. That is easy enough to fix. Still breaks though. Still got problems. And of course we don't have the history. All right, so what do we have in opcode? We have 12, which C, okay, right. No, oh, what have they? How do you call it? T, okay. Oh, right, because it's 4 bits. No, that's what it is. Wait a second. God damn. Feeling not very smart right now, but we need the 4-bit and the 2-bit set for this to be 6. So we are masking off the lower 4 bits here. Or I guess technically we want this because we need the upper 5 bits for our scheme where we're using the low 3 bits to determine certain things, which eventually will just be when it's the register value. Alright, let's give this a shot. Okay, so it did more instructions than I anticipated. So what is that about? Because it should always be returning 1, so we should always be incrementing 1. So, yeah, I don't have a break here. And I could put a break here, but we have a return, so whatever. Okay, cool. So we've got pop and push decoding correctly. I mean, it's a very simple setup, but it does decode those. And we can move on to some of the other ones that are fixed numbers. So this one, they give you all 4 bits, or all 8 bits. But this will have a different setup depending on if we are in 32-bit or 16-bit mode, operand mode. You know what? So going back to what N. Permyakov was saying, and the thing, the PDF that he quoted from AMD's technical docs about the code segment descriptor, what I had always been assuming in some of the, well, I guess this is a good example, right? Because we've got a push A and a push AD. Same opcode, same exact bytes, but it has a different semantics based on if we're talking about 32-bit registers or 16-bit registers. I had always assumed the thing that determined the difference between the operand size being 16-bit or 32-bit was, are we in real mode? Because my thinking is that real mode is always 16 bits, but maybe that is wrong. Even if that is correct, though, it might be additionally possible that how you set the operand mode is through the code segment descriptor, and maybe that's the more common way of switching between operand sizes. Yeah, more to think about. Okay. So what that comes into is there are technically two different instructions for the convert either byte to word or word to double word. Basically, the promote to a larger operand size versus convert. This is again a promote, but just a promote on the larger end, so you could get to a D word. In which case it puts it in 2 registers. Okay, yeah. Which is interesting. I mean, for 16-bit, it really, or for both of these, I mean, this instruction is like just setting a different register. Like the behavior, I get why it is being called convert word to double word, but since the mechanism of it has the double word or the quad word being represented in multiple registers, and you aren't really doing anything with the low part of those combined 2 registers, the semantic result of this instruction is really only barely related to what the description of it is, I would say, which is interesting. Whereas this one is doing actual like sign extension, so that makes sense. Okay. In any case, we have a very similar setup where we can use this plus the low 3 bits to determine if we're doing one of these two. We do have the difference between and you know what, I guess it's technically true that these also have different varieties, whether we're 16-bit or 32-bit. So I'm going to go ahead and throw those on here as well. The name for these instructions is, kind of arbitrary, I would say. I'm going based on what they have from the Intel manual as represented in the Felix Cloutier reference pages. But if we do like pop A, it's got pop A and pop AD. So I'm going to list those as well. And we're going to default right now to and again, like this print function is going to be I'm not going to continue manually putting in all of these instructions. I think sometime before my next stream, I'm going to go in and get some plumbing code in place for the purpose of helpfully printing out the enum values, because I don't want to deal with like extending this switch statement every single time I add a new enum. But for now, that's what we're dealing with. And we will go ahead and have some more of those with, what was it? CBW and CWDE. and we're not going to deal with CDQE. Because again, we're not doing any of the 64-bit stuff for right now. So we'll just deal with the first two. And besides, like, this has the Rex prefix, so therefore it would not be the same instruction, and it's a multi-byte by definition, so not something that we're dealing with at this moment anyways. So yeah, CWDE and CBW. And I'm going to keep with this pattern of doing 16-bit, then 32-bit, 16-bit, then 32-bit, 16, then 32. Okay, so we got those. Then we've got case, what was it? 10011. Yep. And oh, no. I have two more. Oops. Let's just simplify here. So right now, CDQ. We've also got CDW and CDQ. Is that right? CWD. I see that's the reason for the E there. Okay. CDQ, right, is, yeah. Okay, so this is a situation where we've got the same setup. We've got some 5-bit prefix, and then the low 3 bits are either 0 or 1, and that determines which of the instructions we're doing. In this case, it's two fairly related instructions with the push and the pop. And these are sort of related conceptually at least, but they're not like paired in the same way that push and pop are. They're not inverses of each other or anything. This is not reducing a, this is promoting a D word to a quad word, and this is promoting a single word to a D word. But it makes sense that they would be encoded similarly, or at least that they're like, they would work out to having very nearby encodings because they are conceptually similar instructions. And we can throw some of those in there as well in our test case, I suppose. And what are those? 98 and 99. Let's see if this actually works. All right, so then we threw in a 98 for a CWTE, and then a 99, which is the CDQ, and then another 98, which is the CWDE. So seems to work for decoding these instructions. Again, we have stuck to only instructions that are a single byte and have no operands, because that's going to simplify the printing of them. It's going to simplify building the instruction structure. We don't even really need the operands right now. We can just do it this way, I'd say. Still works. Okay. So I've been going for about 3 hours. I'm going to keep this stream at just 3 hours. Sorry for anybody that's popped in relatively recently. I know I have not gone through all of the single byte instructions that have no parameters. We could definitely do these move ones, and we're not going to do the NOP one because I'm going to, as mentioned earlier, I'm going to represent it as this exchange for right now. But I guess we could do XLAT. I don't even really know what XLAT is. Table lookup translation. So translate, I guess, is what that's supposed to be. Interesting. Yeah, I mean, this is such a specific thing that I imagine it just doesn't come up in any modern code. It's one of these very does so much stuff because it was it's probably a relatively common pattern still, looking something up in a table, but doing so with single byte values where we're using AL, and then we were looking something up with a segmented address. We've got a 64-bit version of it, still uses AL as the lookup, so the index, the table is 8 bytes, or rather 8 entries. And I don't know if you get to specify what the size of each of those entries is. I guess it's a single byte because it copies the contents back into the AL register. Yeah, I mean, it just doesn't seem like it's a little too how to put it, it's too specific to how you would have written it way back in the 16-bit days, it would seem. So, but we can, we should support that instruction being decoded, and halt and some of these other ones we can definitely get going on the next stream. But hopefully in the meantime, I'm going to put a little bit of stuff in place so that I'm not spending time, extending this switch case, and maybe I'll even have some test case setups in place so that we aren't just doing this one random stream of instructions that I've written to include the various things. We might even do some work on trying to set the mode correctly for whether we're doing 16-bit operands or 32-bit operands so that we get the proper opcode based on that. That's my thinking right now, and we will go forward from there, I guess. I'm sure so much of this is going to just be thrown away entirely when we have to, start involving operands and stuff of that nature. But I'm okay with what we got going right now. It just doesn't feel, I don't know. It's one of these until I have achieved a certain amount of stuff actually decoding properly, that I can pull some stream of instructions from a source that I didn't, being able to decode the set of instructions that I just wrote that I know conforms exactly to the stuff that I wrote for the decode function doesn't feel as real or as meaningful as if I can just pull a stream of instructions out of some binary and say, you go for it. But that's going to be a while before we have enough instructions working in our decoding process, in our decoding logic, before we can actually do that. But that's when I'll start to feel like this is a thing, basically. Until then, it's like some of the projects that we would give our students when I was working at the coding boot camp, especially the early projects where like really they were just writing a set of test cases, or we had given them a set of test cases and they had to write the code to make them pass. It's so tied to the test case because there's no external use case for it. It feels kind of divorced from reality, the code that you're writing. I don't think this, as students, they really got that sense because they didn't have enough perspective, but I definitely felt it as the instructor of like, you don't have any real guidelines as to how to write something other than this arbitrary choice that we made when we wrote a test case for you. So for now, that's where we'll be at. But as we get enough additional instructions decoding, we might get to a part where we can start feeding it real world data and feel like it's grounded in something real. Okay, that's I'm happy with this as the first coding stream that I've done. I think I feel a little less self-conscious when I'm working on the hacking stuff because it's not something that I have done for a while, whereas in theory I have been writing code for years and shouldn't trip up on little things, but I think I get in my head a little bit too much sometimes when I'm like coding in front of other people and make silly little mistakes. But overall I felt okay about this. So I'm just rambling now, but I'm going to end the stream and just want to remind everybody, check out the schedule tab. I might even decide on one of those schedule panel things that I can put on the about main page thing next to the description and link to the music copyright or whatever. That'll list the schedule. But for now, you can check out the schedule tab and it'll tell you that tomorrow I'm going to be back at the same time, which is like 1:30 p.m. GMT time. And I'll be working on more binary exploitation stuff. I can pull that up right now. So I've gone through all of this stuff up through the bad seed category, and we're going to start on the symbolic execution category, which is something that I only have a very minimal amount of experience with. I can easily foresee this going poorly. And by poorly, I just mean it like I need to learn so much about it that it's not a very interesting stream to watch me read documentation or something. So if it goes down that route too much, if it feels like I need to do more learning before I can actually practice this stuff, then depending on whether anybody on, in chat is interested in watching me struggle to learn a thing, if that's not what people are interested in, then I'll probably skip over to the return-oriented programming stuff. Since we've done several of those on previous streams, I feel like I would be in a good place to try to tackle them. And like, obviously it'll be learning in the sense of like pushing me to do more than I've done before, but it won't be so much like starting from scratch kind of learning, which maybe is too slow to be enjoyable for the audience rather. And then eventually we'll get to heap exploitation, and that'll be really great because that seems the most real world useful stuff and not something that I've ever done. but we're still a ways off from that. So tomorrow I'll come back and I'll start on this first one under the symbolic execution section, and then we'll go back, we'll ping pong back to working on more with the decoder that we did today. And over the weekend, I'll try Hack Me for the first time. I've looked at it, but I haven't done any of them before, so that might be fun to watch me sort of flail about on some of those. Anyways, thank you for watching my stream, for sticking with me. Mishka Blitz, thank you very much for the follow. I appreciate that. I didn't notice it earlier, so sorry for not mentioning it until now. But yeah, thanks for the follow, and have a great night, everybody. All right, OBS died, so I had to pop it back open. Then you might see the little like stream is dead screen for a second, but I am going to end it now abouts.